Recently, very important news has emerged about Solar Sail and Artemis 2. The first news with us says, Rocket Lab to launch NASA's new Solar Sail technology no earlier than April 24. The space agency announced the NASA Solar Sail mission meant to test new space travel materials in Earth's orbit is scheduled to lift off no sooner than April 24. Named the Advanced Composite Solar Sail System, or ACS, the mission's primary goal is to test the deployment of solar sails using new composite booms, which are tube-shaped materials meant to unfurl and hold four very thin triangular sheets tightly. These sheets together form a kite-like solar sail. The ACS booms pull the solar sail into the size of a small apartment from a microwave-sized satellite in under 30 minutes and are stiffer and lighter from previous technology. The spacecraft is scheduled to launch on board Rocket Lab's Electron rocket from the company's launch site in Mahia, New Zealand. Solar sails, which propel payloads by harnessing sunlight the same way sailboats use wind, have gathered momentum in recent years as affordable alternatives for conventional chemically propelled rockets. When particles of light called photons strike a solar sail, they transfer their momentum to that sail. Although slight, such subtle pushes are consistent and can help spacecraft cruise through space, even allowing them to accelerate over time to speeds achievable with conventional rockets. Astrobiologists deem solar sails worthy in the search for alien life on Jupiter's moon Europa and Saturn's moon Enceladus, two ice-covered worlds thought to harbor conditions friendly toward life as we know it in their hidden subsurface oceans. Although previous missions like the Planetary Society's notable LightSail 2 have already demonstrated that small spacecraft can indeed utilize solar sails to travel millions of miles and change orbits as needed, those missions use metal booms which are heavy and could unpredictably morph thanks to sharp temperature swings known to occur in space. Meanwhile, ACS is 4 times bigger than LightSail and uses lighter booms made of carbon fiber reinforced polymer or CFRP, which are strong enough to hold the solar sail tightly while flexible enough to fold compactly for launch. Alan Rhodes, the mission's lead systems engineer at NASA's Ames Research Center in California, said in the statement, 7 meters of the deployable booms can roll up into a shape that fits in your hand. The hope is that the new technologies verified on this spacecraft will inspire others to use them in ways we haven't even considered. Once the spacecraft reaches its predetermined orbit of 1,000 kilometers above Earth's surface, it will begin the 25-minute process of unrolling the composite booms which span the diagonals of the sail. Assuming all goes to plan, the mission would also test changing the spacecraft's orbit via the solar sail, a maneuver that could offer useful data for future missions. Upon complete deployment, the solar sail will measure about 80 square meters, which is roughly as wide as 6 standard parking spots. The space agency predicts the solar sail will be large enough that its shiny reflective surface will sparkle above our planet as brightly as Sirius does, the brightest star in the night sky.
The second news with us says, this little robot can hop in low gravity to explore asteroids. A 3-legged robot named Space Hopper could help combat the challenges of exploring low-gravity environments, such as those found on asteroids or moons. According to a statement from the university, the Space Hopper program was first launched 2.5 years ago as a student research project at ETH Zurich University in Switzerland, and recently researchers tested the hopping robot in a simulated low-gravity environment during a European Space Agency parabolic flight. The robot consists of a triangular body with an articulated leg at each corner. Each of these 3 legs has a knee and a hip joint, allowing the robot to push off from a surface, kick to propel itself through space, and control its landing within a designated area. Space Hopper is designed specifically to explore relatively small celestial bodies such as asteroids and moons where there is little to no gravity. Asteroids are thought to contain valuable mineral resources that could be of use to humankind in the future. The exploration of these bodies could also give us insights into our universe's formation. However, exploring these types of celestial bodies can be challenging. In an environment with almost no gravity, there is basically no traction between a spacecraft's wheels and the surface it drives across. There is barely any atmosphere for a spacecraft to fly through, if there is one at all. That's why Space Hopper instead performs brief hops to move upwards and sideways. The recent parabolic flight allowed the researchers to simulate the low-gravity conditions in which Space Hopper may one day be deployed. A video taken during the flight shows Space Hopper kicking each of its 3 legs in coordinated movements to stay lifted during periods of zero gravity, which occurred about 30 times per flight, for about 20 seconds each.
The last news with us says, Artemis 2 Orion spacecraft starts testing ahead of moon mission with astronauts in 2025. NASA's next moon spacecraft for humans made one small leap into an altitude chamber for vital testing before it brings astronauts on board. The Orion spacecraft for Artemis 2 is slated to fly around the moon with 4 astronauts no earlier than September 2025. But first, engineers with NASA want to make sure it is ready for the job. Testing in a vacuum chamber at NASA's Kennedy Space Center began April 10 to assess Orion for electromagnetic interference and electromagnetic compatibility, NASA officials wrote in a statement. The aim is to make sure the spacecraft can continue working well amid these fields, both spacecraft-generated and space-generated, ahead of the big launch day. NASA wrote there are multiple altitude chambers available at KSC. Orion is in the West Chamber, which was upgraded to test the spacecraft in a vacuum environment that simulates an altitude of up to 76.2 km. Technicians hoisted Orion into that chamber on April 4 using a newly installed 30 tons crane in the building, which can move the stacked Orion crew and service modules into the chamber, manipulate the lid of the chamber and carefully transfer the spacecraft in the building's high bay. While Orion spacecraft have flown to space twice before, this mission will be the first with astronauts on board. It will also test new systems, such as life support. The spacecraft model's previous journeys were the Artemis 1 uncrewed mission to lunar orbit in late 2022 and a brief trip to Earth orbit in 2014. Artemis 2 will kick off the larger crewed Artemis program, which plans to put boots on the moon again with Artemis 3 as soon as 2026. Both missions were delayed in January 2024 due to technical issues. Artemis 2 was pushed back about 9 months, while Artemis 3 is forecast to wait an extra year. The NASA-led Artemis program is eventually slated to put a settlement at the moon's south pole, near water resources that exist there. The Artemis Accords include 35 countries committing to peaceful space exploration norms led by NASA. A subset of those countries, including Canada, are providing hardware for moon missions. Japan, another signatory to Artemis, committed to a pressurized lunar rover for astronauts and will be the first country other than the United States to land an astronaut on the moon, NASA and Japan announced on Wednesday, April 10. Thank you very much for watching. Goodbye.